In this chapter, we're going to learn how to install a purchased certificate. If you already installed a free certificate using Let's Encrypt in the previous chapter, then you can safely skip this entire chapter. In this chapter, we're only going to be looking at paid certificates that come from traditional certificate authorities. The first thing that those certificate authorities are going to want when you go to their website is for you to give them a certificate signing request, or CSR. So let's learn how we create that. The first thing you need to know about certificate signing requests is you should not be tempted to use any of the online CSR generators that are out there. They do the job perfectly fine, but they have a big problem. The first step in creating a CSR is generating a public-private key pair. You'll remember from our discussions about public key cryptography that private key is something we want to keep private. It's not something that we want to generate on some unknown remote website and then transmit over the public internet to our own computer. The private key could be compromised. Either the remote site could keep a copy of it, or someone could see it as it's being transmitted. So we always want to create our key pairs locally. There are a number of different software tools that will let you do that, and they vary by platform. One of the most popular is something called OpenSSL. It's available for a variety of platforms. Many systems come with it pre-installed, or they have it available as a package so that it's very easy for you to download. Once you have it installed, then you can use it to generate a key pair and to create a CSR. And OpenSSL will walk you through the process of creating a CSR by asking you to enter some organization information. The way we're going to interact with OpenSSL is from the command line. We can use the command line in OpenSSL to generate a private key using a command like this: OpenSSL gen RSA. RSA is the type of public key we're creating. And then we tell it the name of the output file we want to use. Here I've got -out and then the name of the file. I've called it domain.key, but you would use whatever domain name you were creating the key for. And then 2048. 2048 is the size of the key. It's the number of bits in the private key. And you're going to want to use 2048. Some certificates are going to require that it be at least 2048. Anything less than that is considered too insecure. Once we have our private key, then we can use it to generate a CSR. We'll again use OpenSSL to do that, but this time we'll use the REQ command with it. OpenSSL REQ-new, because we're creating a new request. REQ is short for request. And then we tell it where to find the key and what we want to use as an output file for our CSR. We can also do both of these steps all in one by using OpenSSL REQ and then using the -new option, and then also providing -new key RSA:2048, and then specifying both the key out and the out. And that tells us what files we're going to use for saving both our private key and the CSR. Most of the time you can just do this third step and do it all in one. It's exactly the same as doing the other two steps. The other two steps have the benefit of you being able to use an existing private key if you wanted, instead of having to create a new one. Let me demonstrate. On my Mac, I'm in the command line, and I'm inside a folder that I've created called ssltest.ssl. Now you can call it anything you want, you can put it anywhere you want. We just want these files to be somewhere where they're not going to get lost. So I'm inside that directory right now, and I'm going to check and see if I have my program. I'm going to use which OpenSSL. And it comes up and says, yes, I know which file to use, which means it is there. So I have that software installed and ready to go. OpenSSL. And then I'm going to use gen RSA. I'm going to use the two-step process. The output file, I'm going to call ssltest.key. And again, it's a 2048-bit key that I'm creating. So there it is. It created the key for me. We can take a look now in the directory, and we see that's there. We can take a look at that file and see it has some information here it's encoded so that we can't read it. It's possible for OpenSSL to decode that so that we could read the content that's there. This is most of the time what your private key is going to look like. So now that we have our private key, let's generate a CSR using it. So OpenSSL REQ this time, because I'm creating a new request. I'm going to use the -new option. -key, I'm going to tell it where to find that key. So that's the file that I just created. And then tell it where to store the output file using the -out option. I'll call that ssltest.csr. So it's going to ask me some questions. I can leave some of them blank, but it's best to try and answer as many as I can because this information is part of my application for my certificate. So I'm going to put in the country code, 2 letters, US, the state or province name. For me, that's going to be Pennsylvania. The locality name, Philadelphia. Organization name, I'll leave that blank. Organization unit, that's very often going to be left blank. The common name, now here it says either put in server FQDN or your name. FQDN stands for fully qualified domain name. So you want to put the full domain name that you're using for this application. So if that's admin.mysite.com, you want to put in the whole thing, including the subdomain at the beginning. This is part of your application. So I'm going to just make this SSL test.site. That's the full domain name that I have. .site is the ending. It's not .com, it's .site. So I'm going to do that. For my email address, I'm going to put in a fake one for now. You'll want to put in your real email address, of course. And then it asks you for some extra attributes. You want to leave these blank. The first one is a challenge password that has absolutely nothing to do with the cryptography or the security of your certificate. This is a password that potentially the certificate authority could use to ask you before you made changes to your site. But the thing is, no one uses it. It's a feature that just no one uses, so just leave it blank. I'll hit return on both those, and now it's done. ls-la. Now you can see I have two files in there. And if we take a look at that SSL test.csr file, you'll see that the certificate request is right here. Now you may be wondering, what happened to our public key, right? We have our private key, that's what we created here. What about the public key? What happened is when we created the CSR, OpenSSL went to the private key, and from the information inside the private key, it was able to deduce the public key, to extract it. So then it was able to take that public key and to put it inside the CSR. We can actually take a peek inside the CSR using OpenSSL. Let me just show you how to do that. OpenSSL req-text-in SSL test.csr and no out. So this is going to show us the text of the request. It's basically going to decode that request for us. You can see what's inside of it. Notice here's all that information I put in, right? In the subject, it has all that information. And then our public key is right here. Public key algorithm tells what kind it is, what bits it is. Everything it needs to know about the public key is right there. That is our public key. So that's the certificate signing request. It's our basic answers to some questions plus our public key. So these are the two key files that we're going to need to enable SSL certificates. The CSR is the public key that we'll submit when getting our certificate. It'll be used for our certificate. This other key is the private key that we're going to put on our web server to be able to encode and decode information with that public key to enable public key cryptography to work. In the previous movie, we learned how to create a certificate signing request. Once we have that, we're ready to go to a certificate authority to sign up for an SSL certificate. You'll remember earlier, I gave you a list of some of the different paid certificate authorities. This is that same list again, and I'm showing them to you in roughly the order of their market share. So based roughly on the number of certificates that each one of these companies provides. I haven't used any of them, so I don't have a favorite to recommend to you. They're all going to offer slightly different features and at slightly different prices, so shop around. What's common about all of them is that you're going to have to choose the domain scope. That's whether you want to have it just for a single domain or a wildcard domain or multi-domain, and you're going to choose the validation level, whether it's domain validated, organization validated, or extended validation. And you may also be asked to choose the time period. Do you want a certificate that's good for 1 year or for 2? And some companies may offer you a discount for signing up for multiple years. Then you'll provide your contact and your billing information, and eventually you'll be asked to upload that certificate signing request file that we created in the last movie. After that, they'll tell you what steps you need to follow in order to get validated. It may be that there's an email that comes into your inbox that you need to respond to, or they may call you up to get you validated. Eventually, once you've been validated, they'll send you a link so that you can download your certificate file. That will be your SSL certificate that's ready for you to install on your website. In this movie, we're going to talk about how to install a purchased SSL certificate on an Apache web server. This is one of the hardest parts of the process of installing an SSL certificate because it requires us to know a little bit about how Apache works and to get in there and mess with those files. And that's not a skill that necessarily everyone has. Most certificate authorities have installation guides to walk you through the process. So you can always look for there as a first place to find information or to help troubleshooting. The number one rule you should remember is that before you start editing any configuration files, make a backup of them. If you have a backup, then if you completely mess things up, you'll always have a file that you can go back to. So just simply copy the existing configuration file before you start making changes. Depending on which version of Apache you have and how you have it configured, those configuration files might be in several different places. The most common are to have it inside the etc directory, in a directory called httpd, or a directory called Apache 2. It's also very common to break up the configuration for different sites into different virtual host files and to store each of those files separately, and those might be in a directory called vhost.d or sites. So you could look for them there. Once you find the file, make a backup, and then you can start editing. What you're typically looking for in one of those virtual host files is something that looks kind of like this. It has something that looks like an HTML tag with those less than and greater than signs on either side of it, and it says virtual host. It might have an IP address or it might have an asterisk, which would be a wildcard, and then it usually ends with :80. That's telling it to listen for requests on port 80. It has your server name, it has document root, and there might be many other directives in there. This is just the simplest possible version. What we want to do is either copy that and make a new directive or edit it. So we have virtual host. Notice now that it says :443. That's very important. That's the one that we're going to use for SSL. It's a different port, not the regular port 80. And we'll talk about that in the next chapter. And then you want to add some directives. You want to tell it to turn on SSL. You want to tell it where to find your SSL certificate file, where to find your private key, and if you've been given a chain file, how to find that chain file. Some companies will give you a single certificate file. Others may include an intermediate certificate file, which may be referred to as a chain file. Remember, we talked early on about how certificate authorities delegate and create a chain of trust from the root certificate down to all these different CAs. Once you've got that configured, then you'll just need to tell Apache to check the configuration. You can do that with Apache CTL space config test, and it'll test out your configuration without doing anything, tell you if you have any errors, and then you'll tell it to restart. Now, restart will just sort of say immediately, let's stop Apache and restart it. I find an even nicer way to do it is with the graceful command that lets any existing connections that might be going on to go ahead and finish up. It doesn't close out log files immediately, things like that. So it's a little more of a graceful restart. So either one of those will get the job done. It'll restart Apache using its new configuration and enabling SSL. Make sure you check out the next chapter though, where we talk about what to do with those connections that are on port 80. In this movie, we're going to learn how to install a purchased SSL certificate on an Nginx web server. Installing the certificate on the web server is one of the hardest parts of the whole process, mostly because you have to go in and edit configuration files for the web server, and that may not be something that you're used to doing. Most certificate authorities have installation guides that can help you through the process. The number one rule is to make sure that you back up any configuration files before you start editing them. That way, if you completely mess up the whole process, you'll still have those working configuration files that you can restore and get things back up and working again. So be sure to make a copy of the working configuration file before you start making changes. Those configuration files are likely going to be stored in a directory called etc and a directory called Nginx. Sometimes they might also be in a directory called opt Nginx. Inside that directory, you should find another directory called sites-available. Now there might also be one called sites-enabled. You don't want to worry about that one. Sites-available is the directory that should contain the configuration files. Sites-enabled should just be links to those files. Inside that directory, you should find a configuration file for your website. It probably looks something like this. It might have a lot of other directives inside there, but it's generally going to say server and then have curly braces. And then the key thing you want to notice is that it says listen space 80. That's letting it know that this is port 80 that it's listening on to get requests. Now, port 80 we'll talk more about in the next chapter, but for now, what we want to do is make another directive, or you can actually change this existing directive. Instead, we want to make sure that it says listen 443 SSL. We're going to, instead of listening on port 80, we're going to be listening on port 443. Now again, this can be a separate directive, the whole thing, server all the way down to the end of the curly braces can be a whole separate one, or you can modify the existing one. Eventually, we're going to have two of them, but for now, it doesn't matter. We just need to have one of them. Notice then after I tell it to listen on port 443, I tell it the path to my certificate file and the path to my private key. Those are the different paths that I'm providing so that it knows how to find both that public key certificate to serve to people and the private key to use to interact with it. Once you've made those changes to the configuration file, you can actually check out the file to see if it works correctly using nginx with whatever command you use to make that run. It's very common to use etc/init.d/nginx in order to access that program. The -t option tells it to just do a test, just to see if the configuration is valid. And then if it is, we can tell it to restart, or if we don't want to completely restart the server, we can actually do a more graceful restart by telling it just to reload its config files without actually restarting the whole program. Either of those would get the job done. Once we've done that, we should be able to connect to our website using HTTPS. Make sure you check out the next chapter though, where we talk about what to do about connections that come in over port 80. In this movie, we'll talk about other ways to install purchased SSL certificates on hosted web servers. If you use a web server that's different from Apache or Nginx and you don't know how to install your SSL certificate, or if you don't have shell access, or if you're just not comfortable editing the web server config files, then you're going to need to have someone help you through that process. Most hosting companies have installation guides to walk you through it. If that still seems daunting, if it still seems like that's too much, and then I don't blame you, it's not an easy process if you're not familiar with it. Most hosting companies will also make the changes for you. You just create a technical support ticket for them, you tell them what you want to do, that you have this SSL certificate, you need help getting it installed on whatever kind of web server you may have, and they usually have people who can do it. For someone who's very familiar with working with these config files, it's a very simple operation, and they can do it in a matter of minutes. For you, it might seem overwhelming because it's something that you don't do frequently, but they can help you out. So your best bet if you feel stuck is to contact the hosting company and ask them for help.